Okay, chapter 9:2. What we're going to do today is graph some of those quadratic functions that we did yesterday. So the key concept here is the properties of the graph of a quadratic function. The graph of ax squared plus bx plus c is a parabola that opens up if a is greater than 0 and opens down if a is less than 0. Okay, so that's one thing you always need to pay attention to, the a right here, that coefficient in front of x. Okay, so basically if it's positive, it's going to open up. If it's negative, it's going to open down. The parabola will be narrower than the graph of y equals x squared, the parent quadratic function, if the absolute value of a is greater than 1, and it'll be wider than y equals x squared if the absolute value of a is less than 1. Okay, so if it's greater than 1, it'll start getting smaller and smaller than y equals x squared. And then the smaller the fraction, the wider the parabola. Now this is a new one. It has an axis of symmetry. You'll understand this in a little bit. An axis of symmetry, which is going to be a line. And that line is going to be x equals negative b over 2a, or negative b divided by 2a. Okay? And the vertex will sit on that axis of symmetry, so the x-coordinate of the vertex is negative b divided by 2a. Now sometimes down in this notes you're going to see it written like this with a negative sign just out front, because again the negative can go with the b, it can go with the 2a, or it can go out front. It doesn't matter. And then a parabola will always have a y-intercept of c. So the point 0c will be on the parabola. Where it intersects the y-axis will always be the c coordinate, or the c right there in the equation. Okay? All right, there's our key concept. We'll be using those kind of as we go through the notes. So for our first example, we're going to just find the axis of symmetry. We're not going to graph anything. We're just going to actually find the axis of symmetry in the vertex. So if we consider the function y equals negative 2x squared plus 12x minus 7, and we want to find the axis of symmetry of the graph and find the vertex of this function. So for the above function, our a is negative 2 and our b is 12. Okay, so we're going to use that in our equation, x equals negative b all over 2a, to find the axis of symmetry. So if our b is 12, if our b is 12 and our a is negative 2, we're going to put a 2 here for the 2 that's in the equation, and a negative 2 in for the a. We're going to solve that. So I'm going to move the negative up here with the 12. And then 2 times negative 2 is negative 4. And then negative 12 divided by negative 4 is positive 3. So then as this statement says right here, the axis of symmetry is the line x equals 3. It will always be a vertical line, a line that goes up and down. And when we graph it, we'll graph it with a dash. But it'll always be a vertical line that divides the parabola in half. Okay. All right, for the to find the x-coordinate of the vertex, or to find the vertex, we already know the x-coordinate. The x-coordinate is negative b over 2a. Well, we just did that up here. So our x-coordinate is going to be 3. We just found it above. So to find the y-coordinate of the vertex, we're going to substitute 3 for x in the function and find y. So we're going to have y equals negative 2 times 3 squared. I'm just substituting it in to find the y value when x is 3. So plus 12 times 3 minus 7. So let's solve this, and we end up with negative 2 times 9. 3 squared is 9. 9 times negative 2 is negative 18. 12 times 3 is 36. And then minus 7. When you combine all those terms, I did negative 7 and negative 18 to get negative 25, and 36 minus 25 is 11. So y equals 11. So the vertex has an x-coordinate of 3 and a y-coordinate of 11. So our vertex point is this, 3, 11. And that makes sense because our vertex should sit right on the axis of symmetry when we're going to graph a parabola, which we're not graphing right now, but just to show you. That vertex should sit right in that middle, on that middle line. Okay? All right, go ahead and pause the video and do the guided practice. All you're going to do is the same thing we did above, the axis of symmetry and the vertex for this function right here. Okay, now that you've paused the video, hopefully you've done the guided practice. First thing we're going to identify is that our A is 1 and our B is -2. And we're going to use our equation, x equals -b over 2a. That will be for our axis of symmetry. Okay, so I'm going to plug that in. Let's see. So a negative and a -2, because that's my b, -2. So I have the negative out front. My b is also negative, so I have both those negatives there together, all over 2 times my a, which is 1. So I end up with a +2 over 2, which 2 divided by 2 equals 1. So my axis of symmetry would be x equals 1. That would be the line, the vertical line, x equals 1, that would divide my parabola in half. Now, to find the vertex of the graph, I already know my x-coordinate. My x-coordinate is right here. It's 1, because I already did -b over 2a. So I already have solved that. So now I'm going to take my x-coordinate for the vertex, and I'm going to put it into the function and solve for y. So I end up with y equals 1 squared minus 2 times 1 minus 3. So 1 squared is 1, -2 times 1 is -2, and then minus 3. So we end up with 1 minus 2, which is -1, and -1 minus 3, which is -4. So our vertex ends up being 1, -4. So there's your guided practice. Okay? All right. Let's go ahead and go to the back. Notice we've used the same thing here. We're going to continue to use that to help us graph. We're going to use this exact information to help us graph, for example, 2. We're going to actually graph the function y equals 3x squared minus 6x plus 2. So the first thing I want to do is determine whether the parabola opens up or down. Kind of always have that in the back of your mind and just know which way you should go. So it opens up, and why does it open up? Hopefully you can fill that in before I tell you. It opens up because A is greater than 0, or A is positive, okay? A is positive. So the first step, or the second step after knowing that, is we're going to find and draw the axis of symmetry using the equation. So I'm going to first identify my A. Okay, my A is 3, and my B is -6. So I'm going to put all this in. So I have a negative times my -6 for my B, all over 2 times my A, which is 3. Okay? When I simplify this, I get a +6 over 6, which just reduces to 1. So my axis of symmetry is the line x equals +1. So I'm going to go to x equals 1, and I'm going to draw just a dashed line of symmetry down the line x equals 1. That is the dividing line for my parabola. Okay? Now I need to find my vertex. Where along this axis of symmetry does my vertex sit? I know it sits on it, but where does it sit? So I'm going to take my x equals 1, so I'm going to use the value from -b over 2a for our x-coordinate, and I'm going to solve for y. So y equals 3 times 1 squared minus 6 times 1 plus 2. Okay, and I end up with 3 minus 6 plus 2. And when I simplify that, 3 minus 6 is negative 3. Negative 3 plus 2 is negative 1. So my vertex is positive 1, negative 1. So I'm going to go to my axis of symmetry, and I'm going to go to positive 1, negative 1, and I'm going to plot my vertex right there. Okay? Okay? Now my parabola opens upward, so I know it's going to be up from here at this point. So the next thing I'm going to do is I'm going to plot 2 points. It says choose 2 x values less than the x coordinate of the vertex. Now I'm going to do that in this case. I'm going to choose values that are less than the x coordinate because that is the side that 0 is on. If my x coordinate were negative, I would choose values that are greater. I tend to always choose the 0 because I'm usually on one side or the other. I try to choose the simplest numbers possible to substitute in. So when x equals 0, you notice I go up here and I put in 0 for x. Well, 3 times 0 squared is just going to be 0, minus 6 times 0, which is also 0. So these two terms just become 0. If I put a 0 in for x in both of these, they become 0, leaving me with just a positive 2. So when x is 0, y is 2. And if you remember back up when we talked about the key concept, we said the y-intercept was always going to be c. So it was a parabola would intersect the y-intercept at the point 0c. Well, that is the case right here, 0 and our c. Okay? So now I don't have to really solve much for that. So now I'm going to put negative 1 in, and I'm going to solve for y. So I'm going to put in 3 times negative 1 squared minus 6 times negative 1 plus 2. And I'm going to end up with, again, negative 1 squared is positive 1, so I'm going to end up with a 3 right here. Negative 6 times negative 1 is positive 6, and a positive 2. And I simplify that all together, and I end up with y equals 11. So my coordinate here is 11. So when x is negative 1, y is 11. So now I'm going to plot these points over here on the graph. I'm going to go over here, and I'm going to go to 0, 2, and I'm going to plot a point. And I'm going to go to negative, did I go to, yeah, I went to 0, 2. Now I'm going to go to negative 1 and positive 11 and plot another point. Now what we learned yesterday with graphing, some of the things we graphed, just the easier ones, is we know that parabolas are symmetrical. So that's why it says reflect the points plotted. So we're going to just completely reflect this one. So if at negative, if at 0 we're at 2, right over here at 2, we're going to also be at 2. Basically look at it this way. 1 away from the axis of symmetry, I'm at positive 2. So 1 on this side of the axis of symmetry, I'm at positive 2. 2 away from the axis of symmetry, I'm at positive 11. So on this side, 2 away from the axis of symmetry, I'm at positive 11. It's just like a reflection. If I'm 1 away from the line of reflection on this side, I'm 1 to the right. If I'm 2 to the left, I'm 2 to the right. That's how it works with a parabola. It's nice and symmetrical. And then once you've reflected your 2 points, you just draw a smooth, or as smooth as possible, graph upward. Okay? I don't have a guided practice for this one because we're just going to practice these in class tomorrow or in class on Monday. So let's go ahead and scroll down to the next example. We have one more example, example 3. It doesn't involve graphing. It's called finding the minimum or maximum value, and it's fairly easy. Okay? It says tell whether the function f of x equals negative 3x squared minus 12x plus 10 has a minimum value or a maximum value. And then we're going to find it. Okay? So because a equals negative 3 and negative 3 is less than 0, the parabola opens down. Since my a term is negative, my parabola opens downward. Okay, so kind of picture it. You don't have to look exact, but picture it opening downward. Okay, my vertex is the very top point. It's the highest point. So the function would have a maximum value, and that would be your y. Okay? The y would be the vertex is at the top instead of at the bottom. It would have a minimum value for a parabola that opens upward and a maximum value for a parabola that opens downward. Okay? So to find the maximum value, you actually literally have to find it. This is the maximum value, but let's actually find it. You're going to start with the x-coordinate using negative b over 2a like we've done every problem. So my a is negative 3, and my b is negative 12. So I'm going to use that. So negative with my negative 12 for my b, all over 2 times negative 3. So I end up with a positive 12 over negative 6, which means that my x-coordinate for my maximum value is a negative 2. So x equals negative 2. Okay? So I found my x equals negative 2. That would be where my axis of symmetry would lie. Okay? And my vertex would have an x-coordinate of negative 2. So I'm going to take that value and I'm going to substitute it into the function and solve for y. And that would give me my maximum value. Okay? So negative 3. Let's solve for y here. Actually, I'm going to put it in like this. F of negative 2. Because that's really what we're doing. We're substituting f of x. Our x is now a negative 2. So I'm going to, for everywhere I see an x, I'm going to put a negative 2. So negative 3 times negative 2 squared minus 12 times negative 2 plus 10. Okay? So negative 3 times negative 2 squared. Well, negative 2 squared is 4, and negative 3 times 4 is negative 12. Negative 12 times negative 2 is positive 24 plus 10. When I simplify that, I end up with 34 right here, and 34 minus 12 is 22. So the maximum value of the function is f of negative 2 equals 22. And also it says that my vertex is negative 2, 22. That would be my vertex as well. Okay? Okay. Daily homework quiz. It's very easy. You can pause the video, bring your daily homework quiz completed to class, please. Thank you.